Students, we're on to the last part of your day one notes, and these are the practice problems you should have tried, and then you're checking to see if you did them correctly. So for the y-intercept, remember that you want to make your x value 0, so you would have 7 minus 13 times 0. Let's try 7 minus 13 times 0. 13 times 0 is 0, so your y-intercept is 7. The zeros of the equation, you want to set your answer equal to 0, so you have 7 minus 13x equals 0. Subtract 7 from both sides, negative 13x equals negative 7, and divide by negative 13, so x is equal to 17 over 13. So let's see, your y-intercept had an x value of 0, so let's make that one 0, 7. And your 0 has an answer of 0, so that would be 7/13, 0. F of negative 2 is when you substitute negative 2 for your x. So f of negative 2 is 7 minus 13 times negative 2, which is 7 plus 26, 33. And f of x equals 8. So your answer is 8. 7 minus 13x equals 8. Subtract 7. Negative 13x equals 1. And divide. All right, here's a radical function, and we're going to find same kinds of values. So for the y-intercept, you're going to put 0 for your x, and you would have square root of 5 minus 4 times 0, which is the square root of 5. The zeros, that would be when your answer is 0, so I have 0 equals root 5 minus 4x, square both sides, and 0 equals 5 minus 4x. Add 4x, that would move it to the left, and divide by 4. So when x is 5/4, you get an answer of 0. All right, f of 2. So I need to substitute 2 for my x. F of 2 is equal to square root 5 minus 4 times 2. F of 2 is going to be the square root of negative 3. So algebraically there's an answer, I root 3, but graphically you would not be able to graph I root 3. So I root 3, but make a note that is not real. Okay, and last one, f of x equals 11. So your answer is 11. So you set your function equal to 11, square both sides, and solve for x. Okay, and negative 29. All right, in the last section we're going to be finding some of the same values, but we're going to be looking at graphs. And the graphs are missing some arrows at the end, so let's see if we can add those in. Here we have an arrow, and here we have an arrow. Right here, and right here. We are going to assume that there are no asymptotes because they are not drawn in. So like right here or right here. So these are arrows are going both to the left and up, both to the right and down. Okay, so your domain starts over here on the left at negative infinity. and it continues along. Looks like there might be a break in the domain, but you see it's picked up at the very same x value here, continues along all the way to the right, and it goes to positive infinity. So your domain is all real numbers, or negative infinity to positive infinity. Your range starts down here where this arrow is pointing at negative infinity. You follow your range up, and it looks like maybe it's stopping here, but if you pay close attention, when you get to the end of your function, this one is going up, 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 up. So because it keeps going up, your range also goes to positive infinity. So your range is negative infinity to positive infinity. Your y-intercept, if your graph represents a function, you should have only one y-intercept, because when the x value is 0, you should have only one y value. So your y-intercept is right there, and it looks like it's at approximately 2. And your zeros. Your zeros are also your x-intercepts, so we're going to see if we can count where these are. 1, 2, 3, 4. The first 0 looks like it's at negative 4. The next one looks like it's at negative 2. And then the last one is right here. Looks like it's approximately 5.5. 1, 2, 3, 4, 5. So we'll say 5.5, 0. Okay, next one. This one does not have arrows at the end, so it has a definite starting point. Let's count back. 1, 2, 3, 4, 5, 6, 7, 8. So the domain starts here at negative 8, and because it has a solid point, we need to include the negative 8. Okay, continues over here. Looks like there could be a gap in the domain, but look, it's picked up right afterwards. Same thing, there could have been a gap, but it's picked up at the same x value. But right here, this hole does create a gap in the domain, because for this x value, there is no y value, so we need to figure out where that is. It's at 1, 2, 3, 4, 5. So we can go from negative 8 to 5, but we don't want to include 5. We're going to get really close to 5 without including it. And then right after 5, we need to pick up again and continue until positive 8, where our domain ends with this endpoint. Oops, backwards. Okay. The smallest value in your range seems to be right here. And your y value is 1, 2, 3, negative 4. Okay. The range continues here. Then you can pick up your y values here. There is a hole here, but that y value is covered with a point right here. So we are going to include this endpoint, and it looks like it might be at 4. 1, 2, 3, 4. So your range is negative 4 to 4. These should both be square brackets. I can't tell that that one's clear, so I'm going to redo it. The square bracket, negative 4 to positive 4 with a square bracket. Okay, the y-intercept is right here. And it looks like it could be about at 1, but actually I can tell where it is because this is a linear equation with a constant slope. So starting here at a y value of 4, I'm going down 1, 2, 3, and over 2. And it does look like that would make it exactly 1. So my y-intercept is 0, 1. Alright, and my 0 is right here. So because I would be going down 3 and over 2, when I go down just one box, I go over 2/3 of a box. So this would be 2/3, comma 0. In some graphs, if you don't know the equation of your graph, it's hard to know exactly where you're crossing, but with a linear equation, you can usually figure it out. Okay, last one. The domain starts over here at negative infinity, Let me just put that on the axes. So your x values start over here at negative infinity, continue, picked up right away right here, and continues to positive infinity. Your range starts down here at negative infinity. And it continues up to here. This point's not included, but it is included over here, so we are going to include our endpoint. So our range is negative infinity, and this would be 1, 2, 3, 4, 5, up to 5. Okay. Your y-intercept, this looks like a square root function right here. So I'm not going to attempt to calculate the y-intercept exactly, but it looks like 1 to negative 3 perhaps. So 0, negative 3, and then the zeros. Alright, the first one is right here. 1, 2, 3, 4, negative 4.5. Approximately. And this one, it's a linear equation, so we're going to try to calculate it. So, starting down here, it looks like we're going up 1, 2, 3, and over 1. So by the time we get here, we've gone over 1/3 more. So 1, 2, 3, 4, 5, 6 and a third. 6 and a third, comma 0. Oh, and it looks like there's one more right here, and I kind of drew on top of it, so I'm going to erase what I drew so I can take a closer look. Okay, so this line's going down, and it went down 1, 2, 3 over 1, down 1, 2, so it would have gone 2/3 more. So let's see where we are. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 2/3. So there would be one more there at 9 and 2/3. Okay, that's the end of the video. Make sure you try your homework and correct your answer with the answer key.